question how many ways without meaning we can arrange the letter. If we don't know about this principle, we just apply the previous theorem. That means here 4 letters, that means n equal to 4, and 4 times we can choose, therefore in 4 factorial ways. That means 4 into 3 into 2 into 1. That means 24. There are different 24 ways. But this is wrong. Okay. So to solve this type of example, this type of problem, there is another theorem. Okay. Here all the letters are not distinct. Okay. There are duplicate of the letters. So if there is duplicate letter is arise, then the permutation number is what? Just write the total number as factorial. Okay, here total letter number is 4, so write 4 factorial, and just divide by which letter is occurred twice, thrice, or first time. Okay, here O is occurred 2 times, so just write here 2 factorial. Okay, so the value will be 4 into 3 into 2 into 1 divided by 2 into 1. So 2 1 will be cancelled out. So there is 12 ways. Okay, this is the right answer. Okay, clear? If suppose there is MOONA, Munna, then the permutation number is here. How many words are letters are there? 3, 3, 6, 7. So we write 7 factorial divided by how many words are repeated? O repeated 4 times. So divided by 4 factorial. So just calculate 4, 6, 5 into 4 factorial divided by 4 factorial. 4 cancel out. 7 into 30. 210 ways. Okay. This type of problem can be solved in this way. Okay. Hi. Welcome back to our channel AnganaStudyCenter. In previous class, we have learned up to the permutation when all objects are distinct, that is 5 factorial, 4 factorial, etc., and do some exercise. Okay. Today we will discuss the next topic of this chapter. If you don't watch the previous video, I request you kindly watch that video. Without that, you can't understand this lesson. Okay. So let's start our class. Now we will learn about the derivation of the formula nPr. Okay. We know nPr equal to n into n minus 1, n minus 2 up to n minus r minus 1. Okay. Where this is the number of permutation. Number of permutation of n different object taken r at a time, and where no repetition allowed, where 0 lesser equal to r lesser equal to n. Okay. So just look at this formula. Now multiplying both the numerator and denominator by what value? N minus r, n minus r minus 1, n minus r minus 2 dot 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 up to 2 into 1. Okay. Now if we multiply the denominator and the numerator, we have nPr equal to n minus 1, n minus 2 dot 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 n minus r. As we multiply with this, n minus r minus 1 dot 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 up to 2 into 1, and in the denominator there will be n minus r minus 1 up to 1. So this can be written as, by the formula of n factorial, we write n factorial equal to n into n minus 1. This is the form of that up to 1, from n to 1. So this can be written as n factorial. And here just look, here the first term is n minus r and up to 1. So this can be written as n minus r factorial. Okay, where 0 lesser equal to r lesser equal to n. Okay, this formula is very very important. We use this formula to solve various problems. Okay, so this should be remembered. Now if n equal to r, sorry, r equal to n, then nPr equal to nPn equal to n factorial divided by n minus r factorial, that means n factorial divided by r equal to n. So n minus n factorial, that means n factorial divided by 0 factorial. As 0 factorial equal to 1, so this is n factorial. Okay. This also remember. Okay. Now we have learned the permutation number of n different objects taken are at a time when repetition is not allowed. If there is repetition allowed, well, what is the number of the permutation? I don't know. Just look. Permutation of the different number of n objects taken at times are at a time where repetition is allowed. Then the number of the permutation is n to the power r. This is the theorem. Okay. In previous class we have done an example. Just think the word rows. Okay. If there is a question, how many words with or without meaning can we form from this? How many words with or without meaning can be formed? Okay. By the theorem nPr, we can do this. Here, just look. In rows there is total number of letter is 4. So here 4 different objects. So here 4 different objects. Therefore n equal to 4. And we can rearranging all the letters. That means that 4 letters. So 4 letters can be taken. Okay. So here the r equal to 4. Therefore r equal to 4. So now the number of permutation is nPr, that means here n equal to 4, r equal to 4, that means 4p4 equal to 4 factorial divided by 4 minus 4 factorial, that means 4 factorial divided by 0 factorial, that means 4 factorial. 4 factorial equal to 4 into 3 into 2 into 1, that means 24. Okay, in 24. If this value will be taken when repetition is not allowed, when repetition is not allowed. Okay. If there is repetition allowed, then the number of permutation is 8. Repetition is allowed, then the permutation number is what? We have done n to the power r. Here n equal to 4 and r equal to 4. So n to the power r equal to 4 to the power 4. That means 16 into 16. So 256. Okay. Till now we have learned about the permutation when all objects are distinct. Okay. Now we are going to learn about the permutation when all objects are not distinct. Okay. Suppose there is a word moon. Okay. Here just look, the letter O occur 2 times. Here 1 time, here 2 times. Okay. Letter O occur 2 times. Okay. If there is a question, how many ways without meaning we can arrange the letter? If we don't know about this principle, we just apply the previous theorem. That means here 4 letters, that means n equal to 4, and 4 times we can choose. Therefore, in 4 factorial ways. That means 4 into 3 into 2 into 1. That means 24. There are different 24 ways. But this is wrong. Okay. So to solve this type of example, this type of problem, there is another theorem. Okay. Here all the letters are not distinct. Okay. There are duplicate of the letters. So if there is duplicate letter is arise, then the permutation number is what? Just write the total number as factorial. Okay. Here total letter number is 4. So write 4 factorial. And just divide by which letter is occur twice, thrice or first time. Okay. Here O is occur 2 times. So just write here 2 factorial. Okay. So the value will be 4 into 3 into 2 into 1 divided by 2 into 1. So 2 1 will be cancelled out. So there is 12 ways. Okay. This is the right answer. Okay. Clear? If suppose there is MOONA, Munna, then the permutation number is Here, how many words are letters are here? 3, 3, 6, 7. So we write 7 factorial divided by. How many words are repeated? O repeated 4 times. So divided by 4 factorial. So just calculate 4, 6, 5 into 4 factorial divided by 4 factorial. 4 will cancel out. 7 into 30. 210 ways. Okay. This type of problem can be solved in this way. Okay. To solve this type of example, we have a theorem. If the permutation number of n objects where p objects are same kind, okay, and the rest are different, then the permutation number is n factorial by p factorial. Okay, this is the general formula. If there is among n objects p1 are of same kind, p2 are of same kind, pk are of same kind, and rest will be different. Rest are different. Then the permutation number is n factorial divided by p1 factorial dot p2 factorial dot pk factorial. Okay, this is also the formula. From this general formula, this formula has been arised. Okay, clear? Let's do some example. Here, example number 9 of your NCERT textbook. Find the number of permutation of the letters of the word Allahabad. Okay, just look. Here, L is repeated 2 times. Okay, so L repeated 2 times. A repeated 2, 3, and 4 times. So A repeated 4 times. Okay, and let's start the same. So total word equal to total letter equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9. That is equal to n. Okay. So therefore total number of permutation is 9 factorial divided by here repeated letters factorial, that means 2 factorial into 4 factorial. So this can be written as 9 into 8 into 7 into 6 into 5 into 4 factorial divided by 2 factorial into 4 factorial. 4 factorial will be cancelled out, and 2 factorial equal to 2. Therefore we can write this as 9 into 8 into 7 into 3 into 5. This will be 7560. Okay. Look at this question. How many 4-digit number can be formed by using the digit 1 to 9 if repetition is not allowed? So the n object, that means 1 to 9, that means 9, n equal to 9. Yeah, total object equal to n equal to 9, that means 1 to 9. So from here 4 digit will be produced. Okay, so r equal to 4. So now therefore the required numbers are p, here n equal to 9 and 9p 4, that means 9 factorial divided by 9 minus 4 factorial. So equal to 9 factorial equal to 9 into 8 into 7 into 6 into 5 factorial. Okay, divided by, here I write 5 factorial. Why? Just look, 9 minus 4 equal to 5 factorial. So 5 factorial will be cancelled out. So 9 into 8 into 7 into 6. This value will be 2, 4. Okay. Just look at this example. How many numbers are lying between 100 and 1000 can be formed with the digit 0, 1, 2, 3, 4, 5 if repetition is not allowed? Okay. So first you think the numbers are lying between 100 and 1000. So the number should be 3-digit number. Okay. So the number should be 3-digit number. Okay. So we are going to find the number of permutation of 3-digit number occurred from this number. Okay. So there is 1, 2, 3, 4, 5, 6 numbers. So if we form 3-digit number from 6 number, the permutation number is, so the total permutation number is 6p3, as 3-digit number will be produced from this 6 letter. Okay. So this is the total number of permutation. Okay. Now there is a thing. We have to find 3-digit number. Here 0 exists. So if this type of number 0, 1, 2 will occur, then this is not a 3-digit number. Okay. So we are going to find this, how many this type of number will occur. So 0, 1, 2, 0, 2, 3, dot, 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 dot. The total number of this type of number is what? Here, if you remove 0 from this 6 letter, there is only 5 numbers. Okay. So, and you are going to find this only 2-digit number, as 0, 1, 2 will be read as 12. Okay. So this is 2-digit number. So the total number is, among the 6, 0, if 0 will be removed, there is only 5 numbers. So 5p, and here 0 will be removed, there will be 2 numbers. Okay. So now therefore the required 3-digit number will be, number can be found equal to 6p3 minus 5p2. Okay. That means, just simplify that, 6 factorial divided by 3 factorial minus 5 factorial divided by 3 factorial. Okay. Just LCM this 5 factorial, 6 minus 1, that means 5, and here 3 factorial. So I am doing here just 5 factorial equal to 5 into 4 into 3 factorial divided by 3 factorial into 5. Okay. Just cancel out these 2, we get 25 into 4, that means 100. Okay. 100 will be the answer. Okay. Now for this 2, here find the value of n when np5 equal to 42, np3 where n greater than 4. Just np5 equal to n into n minus 1 into n minus 2 n minus 3 n minus equal to 42 into here n into n minus 1 n minus 2. Okay. So as n greater than 4, therefore n into n minus 1 n minus 2 not equal to 0. So from this we can write, or n minus 3 into n minus 4 equal to 42, or n square minus 7n minus 30 equal to 0, or n square minus 10n minus 3n minus 30 equal to 0. So if we factor this, we can get, or n minus 10 into n minus 3 equal to 0. Therefore n equal to 10 or n equal to 3. As n greater than 4, n not equal to 3, therefore n equal to 10. Okay. This is the same type of this, so this is your homework. Okay. Just look at this question. Find r if 5 4pr equal to 6 into 5p r minus 1. Just simplify this. 5 into 4 factorial divided by 4 minus r factorial. Okay. Equal to 6 into 5 factorial divided by 5 minus r plus 1 factorial. Okay. This implies 5 into 4 factorial divided by 4 minus r factorial equal to 6 into 5 into 5 factorial can be written 5 into 4 factorial. Okay. And this can be written as, this is the 6 minus r factorial. Okay. So this can be written as 4 factorial will be cancelled out, and 5 will be cancelled out. So 1 by 4 minus r factorial equal to 6 by 6 minus r into 6 minus r minus 1, that means 5 minus r. 6 minus r minus 2 equal to 4 minus r factorial. 4 minus r factorial. Okay. Now 4 minus r factorial, 4 minus r factorial will be cancelled out. Now I am doing here 1 equal to 6 by 6 minus r into 5 minus r. Just simplifying this, we get 30 minus 11 r plus r square minus 6 equal to 0, or 24 minus 11 r plus r square equal to 0. Okay. Therefore, or if we factor this, r minus 8, r minus 3 equal to 0. Therefore, r equal to either 8 or 3. So this is the answer. Okay. Now look at this question. Here, find the number of permutation of different 8 letters that can be made from the word daughter. Here, 3, 6, 7, 8. So, if there is no condition, we can write this 8 letter can be the permutation of this 8 letter occurrence is 8 factorial. The total number of permutation is 8 factorial. That means 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1 equal to, what is the value? 40320. Just multiplying this. Now, for the question 1, all vowel occur together. If this type of question arises, just look what are the vowel in this? A, U, E. Okay, so we should write A, U, E. When this will be occur together, then we consider as a one letter. This 3 as a one letter. Okay, so this 3 will be 1. Here D occur 1 times, G occurs 1 times, H occurs 1 times, T occurs 1 times, and R occurs 1 times. Okay, so how many letters are there? 1, 2, 3, 4, 5, 6. Okay, so there are 6 letters. So when the permutation number is when vowel occur together is just here this 6 letter can be occur in 6 factorial way. Okay, and here just look, these 3 vowel can be occurred in 3 factorial way. So just multiply with 3 factorial. Okay, as there is no repetition of word in this and this vowel also, so 6 factorial or 3 factorial is not divided by some number. Okay, so just multiplying this, we get 6 into 5 into 4 into 3 into 2 into 1. Okay, and this is 3 into 2 into 1, and this will be 320. Okay, and for this 2, there is all the vowel do not occur together. So if we minus from this, if we minus this value from this, that is the permutation number of all vowel do not occur together. So the required permutation number is 40320 minus 4320. That means 00063. 36,000. Okay, and look at this example. In how many ways can 4 red, 3 yellow, and 2 green discs can be arranged in a row if the discs of same color are indistinguished? Okay, here total number of red color discs is 4. Total number of yellow color discs is 3. Total number of red color disc is 4. Total number of yellow color disc is 3, and total number of green color disc is 2. So total number of discs is 9. Okay, the required arrangement is, that means required number of permutation is, therefore total number of permutation is here 9 factorial divided by red color occur 4 times, that means divided by 4 factorial into, here yellow color occur 3 times, that means 3 factorial into green color 2 times, that means 2 factorial. Just solving this, 9 into 8 into 7 into 6 into 5 into 4 factorial divided by 4 factorial into 3 factorial into 2 factorial. Just cancel out these 2, and we can write this as 9 into 8 into 7 into 6 into 5 divided by 3 into 2 into 2. Just cancel out 3, 2, 6, and here 4. Therefore, we have 63 into 20. That means 1260. Okay. Now look at this question. Find the number of arrangements of the letters of the word independence. Okay. Number 1. Do the word start with P? Question 2. All the vowels always occur together. All the vowels don't occur together. And when do the word begin with I and end with P? So first we will find the total permutation number where all the letters are there. Okay. So the total number of permutation is here in the word independence there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 letters, that means 12 divided by which letter are repeated? Here I is not repeated, so we can't write n. N repeated 1, 2, 3 times, so 3 factorial n2. Here D repeated 2 times, so 2 factorial. E repeated 1, 2, 3, 4 times, that means 4 factorial. P repeated 1 times, N repeated 2 times, okay, N repeated 3 times, D repeated 2 times, E repeated 4 times, N repeated 2 times, and C repeated 1 times. So this is the permutation number. So just solving this, we get 12 into 11 into 10 into 9 into 8 into 7 into 6 into 5 into 4 factorial, okay, divided by 3 factorial equal to 3 into 2 into 2 factorial equal to 2 into 1 into 4 factorial. Just cancel out these two. We get 3, 2, 6 will be cancelled out, and here 6 will be cancelled. 1, 6, 6, 3, 2, 0, 0. Okay. This is the total number of permutation. Okay. Now for the question 1, do the word start with P? Let here just draw this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Here the first letter is P. This is fixed. Okay. So from this word we cancel out P. Okay. If we cancel out P, then there are 11 what? Okay. Sorry, 11 letter. Now among the 11 letter, the total permutation number is, therefore the required permutation number is, as there is 11 word, 11 letters, so 11 factorial divided by here. Then look how which letters are repeated. So here N 3 times repeated, into D 2 times repeated, E 4 times repeated. So this will be the value. So by solving this we can get 11 into 10 into 9 into 8 into 7 into 6 into 5 into 4 factorial. Okay, divided by 3 into 2 into 2 into 4 factorial. Just cancel out 4 factorial we get, and 3 to 6, and this is 4. So 11 into 10 into 9 into 7 into 5 into 4. 1, 3, 8, 6, 0, 0. Okay. Now for this 2, when vowels are occurred together, that means here vowels are I, E. Okay. So here I occurs 1 time and E occurs 4 times. So we can write this as a letter. Okay. Therefore, after this 5 letter, there are only 7 letter, and if we consider this as 1 letter, so 7 letter plus 1 letter, that means total 8 letter. Okay. So the required permutation is 8 factorial divided by within these 8 letters, which letter are occur in several times, that means there is repetition. Here then look, N repeated 2 times, that means divided by 2 factorial, and D repeated, N repeated 3 times, sorry, and D repeated 2 times, into, why into? As there is 5 vowels. 5 vowels, so these 5 vowels can be arranged as 5 factorial divided by 4 factorial as repetition of E. So this will be the value. That means by solving this we get 8 factorial equal to 8 into 7 into 6 into 5 into 4 factorial. Okay, and 5 factorial equal to 5 into 4 into 3 factorial divided by 3 factorial into 2 factorial into 4 factorial. Just cancel out this 3 factorial, 4 factorial, and we have 8 into 7 into 6 into 5 into 5 into 4 divided by 2. Just cancel out this 2, we get 200 into 200 16,800. So this is the permutation number if vowel occurs together. Then for the question number 3, what will be the permutation number when vowels don't always occur together? So just minus this from this. So the required permutation, I write P, is 1663200 minus 16800. Just minus this 004 1646400. Okay. Now for this 4, there is do the word begin with I and end with P. That means in the first place I fixed and in the last place P is fixed. Therefore there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So this 10 letter can be arranged. So therefore the permutation number is 10 factorial divided by. So here just cancel I and P. So there is this 10 number here. N occurred 3 times. That means 3 factorial divided into D occurred 2 times. Okay. E occurred 4 times. Okay. And rest are not occurred several times. So just calculate this. 10 into 9 into 8 into 7 into 5 into 6 into 5 into 4 factorial divided by 3 into 2 into 2 into 4 factorial. Just cancel out this 2 and this 4. We have 10 into 9 into 7 into 5 into 4. So we have 63 into 200. Therefore 12,600. Okay. So that's all for today's class. Kindly practice all that things we have covered in this class. If you like this video, then please click on the like button and subscribe our channel. If you like this video, please share with your friend. Thanks for watching our class.